SIB. Fine. Now, if you carefully see, like the words that are used there, scale, index. Okay, these are the two important words which are to be considered there, irrespective of like what exactly or how exactly it works. Correct. So now when we see like appropriately the way that we identified that mod RM byte contains three different components, SIB also contains three different components. Fine. And those components would be playing an important role uh, ultimately every time whenever we are working with, say, operands where there would be something more included. Correct. So say for example, like the way that I wrote a code that day when we tried accessing some elements appropriately from the array. Correct. Now what happens if at all I do really talk about, say, the code where the way that we computed the address, like we said base plus index multiplied by size. Now that size would be scaling factor. So that size scaling would be with respect to 0, 2, 4, 8. See, as per the data types, if you see what we saw, data types, I mean to say the minimum requirement with for storing or allocating number of bytes for a variable through data section or BSS. We saw that there is DB, a byte, there is there is DW, which reserves 2 bytes, and there is DD, which reserves 4 bytes. Though we haven't used, but there is something called as DQ as well, which stores 4 bytes, a quad, define quad. So quad would be used whenever you are having a float point value. Float point value. Now, when we do deal with such kind of quad operation, so like the scaling would be according to that factor. Fine. So like if I see, so let me write scale index, let us say base. This is for your scale index base byte. Fine. So let us really see what happens with that scale index byte. Yeah. Scale index base, this SIB. Fine. So like if I assume this would be scale, this would be index, and this would be base. Like with assumption, I'm saying that these are the 8-bit positions. How I divided that? So I divided 2, 3, 3. So this would be scale, this would be index, this would be byte. So scale would have values 0, 0, 0, 1, 1, 0, 1, 1. This index and base, most of the time they would be used as registers. So we already have now values associated with them from 0, 0, 0 to 1, 1, 1. Now even we saw that if memory is used at some point of time, like base probably in my earlier code was array. Correct. If it is array included over there, array would be used as a base address. If you recall in the previous session, I used 100 as a starting address. 100 plus index was taken as 1 multiplied by 4. Index taken as 0 multiplied by 4. Index taken as 2 multiplied by 4. So we computed 100, 104, 108 and so on. Similarly, like at that point of time, like index and base would be your probably registers, or they may be the addresses associated with the particular array or memory location. So either you associate memory location with the register or you associate or you directly take that base address as it is. Like the way that I referred array, I could have written it as ESI. Like if I don't write move ESI comma array, I could have written that array directly instead of ESI. Right. So they most of the time these would be the values like running from what would be the possible value 0 0 0 0 0 1. So you keep on doing this 0 0. So if I write 0 0 0, last value would be 1 1 1. So if I leave apart in between values. Now 0 0 0 0 1, then you have 0 0 0. Now you have again those values 0 0. So let us say dot 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 0 0 1 1 1 1. This would be last. So appropriately you will see that those eight values would be picked as per the position for base as well as for index. Now one of them would be used like if at all a memory is used. So if I go there the way that we saw mod rm table for 32-bit. This was mod rm table for 32-bit, correct? Fine. So similarly, you may find a scale index base here. You will see you cannot use ESP in bracket. You cannot see ESP in bracket. You cannot use ESP in bracket. You cannot use ESP and see the index. So it looks like you are talking about probably 1 multiplied by 1 because I cannot take 0. Multiplied by 0 would not be possible because you cannot refer to an address which is multiplied by 0. So 1, 2, 4, 8 as per our types. Define byte, define word, define double, define quad. Though we haven't used quad at perspective time. So if you are using any memory location there, this none would be coming into picture. Correct. So let us try to really understand this. So what was the like if you see those register values are kept same 0 0 0 0 0 1 and you will see that there is nothing called 8-bit or 16-bit. It is always for 32-bit because it is 32-bit addressing. There is nothing called you cannot use EBX or kind of registers in between. Only BX or BHBL and so on. Fine. Okay, let us try writing this code. So this is for today. So I'm directly now using text section. Global. Now I am not taking any memory here. By the way, I will use only registers. So main move EAX comma in bracket EBX. So add EAX comma EBX. So let me take this. Fine. Sorry. Let me save this. Let me now translate this. Nasm dash IPLF 32 1903 dash L p.lst. Let us see that p.lst. Now this was taken here as directly mod 03 and 03. Correct? Because probably I haven't used any scale factor in between. So if I write base plus index multiplied by scale. So we are talking about this. Now when I took only this, say for example, let me show you this. When I took only EX, so this was my mod RM. This was my mod RM, correct? Now when I made that change in my code by adding one more register there, let us see what happens. Now you will see one more byte is added. EBX plus ECX. Now, do I have any multiplicative factor for ECX? Right now, no. So it is assumed that it is multiplied by 1. So let us go here to our window, and this was our earlier case. So we have, say, so let me take 0B. How will you write 0B? By the way, how will you write 0B? Tell me in binary 0 0 0 0. Then B means what?
1 0 1 1.
Very good. 1 0
1
1 1.
0 1.
Very good. So let us differentiate this. Now here, this is our base address. EBX is base, ECX is index. So like as per base SIB, this was scale was 0 0. Index register, which is index register? ECX. Correct? In this case, ECX would be used as an index register. So actually, though I haven't written this, it is like EBX plus ECX multiplied by 1. Multiplied by 1. Correct here. This is ECX multiplied by 1. So I am talking about now first row. So ECX is index register. So base we are taking 0. This is ECX. You can see, and this is EBX. So that's the reason why this 0B came into picture. Is that fine now? Understood?
Yes, sir.
Okay. Now suppose we want this value. We want this value 3D. No, let us not take 3D, but let us take 3E. Okay, 3E. So you will see that these registers are scaled indexes. Scaled indexes. So in bracket, this also would be in bracket, but this would be used as a base. You can see R32 decimal base is EAX, ECX. These would be base registers. So I want what? 3E. So 3E, ESI and EDI is to be used. You can see EDI and ESI to be used. So we want 3E. So let us go and let us write the code. Let us input that in the code. Move EX comma ESI plus EDI. Correct? ESI plus EDI. So we wanted 3E. Remember that. Can you see 3E? Correct?
Yes.
Now that means what? Whenever I am referring to this, like if I replace it by base, let me take base value. And let us see, are we going to get this 0, 5 and so on there? This whole column. Okay, let us make that change. So I assume now rest of the things can be understood by you. Okay, so I am not talking about this index right now. This row I'm not talking about this 1 0 0 20 21 20. I am not talking about that row. I'm talking about now this row 0 5 0 D 1 5. Let us see. Where is my code? Yeah. So let me add. Okay, let us take this. Sorry. BSS base reg D1. Move EX comma base plus EX ECX EDX EVP ESI and I am not purposefully taking is ESP there because ESP is not there. Fine, let us see now what it displays. Are you with me? So I'm adding a base. Okay, there. Let us translate this. Now this base came into picture. Even we see 80 came into picture. 80, 81, 82, 83. So what happened here? Though I took base, if I go back to my code, sorry, my table. Where is 80? It is occurring somewhere here. So I don't mean that thing. I don't mean that thing. So that means what exactly it did here, it hasn't taken this as SIB. This was mod. Mod RM. Mod RM was taken every place. And this 80, 80, 0, 8, 80, 80, 81, 82, 83, whatever came because of these registers. Correct. Now, if at all I want that 05 to be added there, what should I do then? Now, let me make the change. Let me see like if I can do, if I can try something else. So now we understood that this is not done. Correct. Let me check this. Now let us see what it does. It says, oh sorry, I must have used the wrong thing. Base comma. Oh, this two came. That is the reason. 11. So it is not permitting me something like this. Because here this is a memory. And this is it is taking this data from somewhere. So if I write the word of, let us see. Even still it is because it is working with memory kind of stuff over there. So yes. So this would not be correct. So if I replace it by say EX base comma index, and here I'm saying move the word of index comma 4, move the word of base comma ESP. Impossible segment based multiplier, I think. Yeah. So segment and base register was taken wrongly. That's what it is saying now. Line number 14. So ultimately, it is not helping me this way too. So let me make the change. If I do this, still that means what it is not permitting me to make use of such kind of combination over there too. So if I write multiply by 1, let us see. Correct. So it is giving me similar kind of error for this line number 14. So definitely it is not permitting me to make use of this. So if I use now this as EX move EX comma base. Now it permitted. Now if I write this LST, let me see. But still, it is not showing me because it is showing still me mod RM. It is not showing me yes this other one. So this would be tricky now to get that particular column which I was targeting. So probably this could be tricky with respect to this case. This column and this row for none. But if I replace it by any other register, then it could be true. It could work well for me. So if I write here ECX. Sorry. Less p.lst. Now I can see the 08. Correct, because it is working like that, the way that earlier we saw. So 08 was formed. See here, 08 was formed because of this EAX and ECX together. So now here I can see that this was for EBP and this was for ESI. So base can be my stack. But if I don't want this, that EBP should not be used there, and that's the thing. So if I go back, try few more things. If I use EBP here, let us see what it does. Sorry. It translated this. You can see 28 came here. 28 was displayed. So where is that 28? Where is that 28? 28 is here because it is taking that EBP there. So this was taken as a base pointer. That's why we took EBP multiplied by 1. So we took it as index. So if I replace that by ESP, let us see what happens. We are getting 0.4. Now we are achieving that somehow. See, we are getting this base. Because here, like this ESP multiplied by 1. Where is ESP? So actually, I am not permitted to make use of ESP multiplied by 1. So it is actually assuming there is EAX and ESP. So like how come this is if I see this EAX ESP. So what exactly it took? It took that ESP as a base and EAX as the index. If I see that 4, translation of 4. ESP was taken as a base. Because I can never take ESP as index. That's what it says. And that's the reason it internally adjusted that to 0.4. Actually, by my earlier discussion, this was base and this was index for me. Now, if I make the change there, let me exchange the values of ESP and EAX. Let me see what I get. So this multiplied by 1 is not playing any role there at all. Actually, both the instructions are same for it. So multiply by 1, ESP plus EX would be taken there. That's what you can see here. Now if I change it to 2, then probably I may see probably the change. Let us see that. Because it is going to change the whole stuff of discussion. Now it is giving me error. And line number 15, only one place it gave me error. I made change at 2 places. Line number 15, error was given here because you cannot use ESP as an index register. So that's what if you see in the table, ESP was not mentioned there. Correct? Now if I take EBP as a base here, so let me certainly make this ESP. Now see, 5 4, there is 45. 5 4 45. Where is 45? And we got 0 0 there for something. Where is 45? See here. This 45 came into picture when it was base was used as EBP. You can see in my instruction I used EBP as a base and EAX as an index. Now in both the case, like okay, let me make the change again. Let me make ECX, the second register. $45, then 4D. I am getting 0 0. Okay, that this 0 0, like what it is for, we will work out. Let us not much worry about. We are getting something which is 0 0. We are not sure about that 0 0 right now, because if I see the pattern that is followed, so will that 0 0 would continue? So now we got 4D. So let us see where is 4D. This 4D, because you are using ECX there, multiplication factor. So similarly, if I go back in the code, if I write this, then see what happens. 0 5 and 0D. So we got that column 0 5 and 0D. Correct? 0 5 0D. We got 45 4D. Correct? So like whenever EBP is as a base, so probably it is adding 0. But when none of the other register is used, like other than EBP is used, this 0 0 never occurs. So this 0 0 would be definitely playing something important. So if you see, if I try to like uh, write this 45 and 4D in our binary form, let us write 45. How 45 would be? 0 1 0 0 0 1 0 1. Correct? To differentiate this. Now in that instruction 0 1 is mod. Sorry, not mod, but scale, because we used multiplied by 2. So for 2, it is 0 1. Now registers are EBP and EAX. This is EAX and EBP. Let us see what is EBP. EBP was taken as 101. You can see 101. Correct. Now next we had 4D. 4D means what? 0 1 0 0. Now D means what? A B C D. A B C D 10 11 12 13. It is 13. So 8 plus 4 like this. So you can see that this is for ECX and this is for EBP. So 4D was meant for ECX and EBP. So ECX and that EBP, because EBP is not there. That's why this 4D. And in the code as well, you can see EBP and ECX was picked. Now what happens if I replace EBP by ESP? Base register is ESP. So I should get that column. See that 0, 0 is not added now. 0, 4, 0C, 4, 4, 4C. So same column for ESP. 0, 4, 0C, 4, 4, 4C. So if I multiply by 4, then I should get 84, 80C. If I multiply by 8, I should get C4CC. Let us see. Are you going to get it? So I'm using 8 and 4 factor now. Let us see. Now these are the ones. 444C, 84, 848C, C4CC. Check the code. Huh? So we want 84. See this 84. 84, 8C, C4, CC. So if I maximize this, now you would be able to see how we got 84. 84 was because of EX multiplied by 4 and ESP was used. Correct. So let us see that 84. ESP was used, EX multiplied by 4. So 84. Now in other case, ECX multiplied by 4 and ESP should be there. That's why 8C. See here 8C. Where is 8C? Yeah, this one. ECX multiplied by 4, ESP. Now for E8, EX multiplied by 8 and ESP C4. EX multiplied by 8 and C4. We got this. We got this. Now in front of us, now there is a black hole for us. That black hole was only meant for this 0, 0. Why this 0, 0 came into picture? Was it because of EVP? Yes, probably. But I have to prove that for EBP only it is coming, and how exactly it is using. Let us not conclude about it. So let me first. I hope you are with me, and you understood that SIB now for a while. Except that ESP row in this table, we haven't talked about this row. Okay, this none. We haven't talked about this. When it is to be taken, we will work out. Okay, right now, except this, at least we got this row. Sorry, this column 050D 454D. We know now how to get that. So I will transfer both the text file and this for your reference. So refer these two for your understanding later. Fine. So let me go back. Now let me add. Okay, let us not take data first. Text. So let us write this now. We want it to be computed for all. EX plus EX multiplied by 1. So I will take ECX here. So even if you don't write multiplication, it would be taken. Now I'm taking 1, 2, 4, 8 EX ECX column. So if I see this table, EX and ECX combination. multiplication factor was with ECX as my code, correct? As my code, multiplicative index was ECX. So I should see row for ECX. So I want probably 08, 48, 88 and C8. Let us see. Can you see that? We got them 08, 48, 88 and C8. Am I right?
Yes.
Now, this is also clear for us. At least we could conclude by saying, OK, whenever we are working with SIB, SIB would be taking a scaling into factor, and when it came 08 for scale factor, what I used earlier, this 0001, this was for scale 2. This was for scale it by 4, and this was for scale with 8. Fine. So OK, let me remove that file first from. OK, let me overwrite this. Replace. Yeah, so now we have something concrete with us with respect to mod RM. Now I'm still not trying to answer purposefully for this part, this none part. I'm not answering that forward. I'm not addressing that part. And as also, I'm not addressing that part with respect to 00. I want you to find out till like you take a week to find out this. But certainly there is something which we need to understand. How can I get that other part over there? Correct. So how can I get that 2021? Yeah, 20, 21, 22, 60, 61, 62, A0, A1, A2, and E0, E1, E2. How do I get it? Because we already saw resolve this issue with respect to 0, 5, 0, 0, and so on. Fine. OK, so let us make the, let us see something new. I hope you understood now SIB except that 0, 0 part and ESP's row. Any question till this? If you don't respond, I will assume that there is no question. Is that fine? OK, so even you are not answering there. Good. Now let me try writing a code. OK. Where we'll see like some different things. So though when I say I'm writing code, this is a temporary thing that I'm trying to write. It's not doing anything which would be kind of important. OK, in the sense of programming, I'm only trying to get the instructions and their translations. Can I write this? Let us see. Now I'm changing the operands order. Okay. X, O. So it is not permitting directly that part. Okay, good. So if I write E6 multiplied by 2. Now when it worked, let me see LST. Whenever we are using any reference which is defined in either a data or BSS section, you will see that that address would be written here along with this 09. Now let us find out where is 09. Where is 09? It is for ECX. Now if you see, when it takes at as 09, 84 is definitely there. Correct. This 84 is playing some important role through what you can call it as mod RM as well. So if I see 84 mod RM, where is 84? 84 is this. Some displacement. Correct. Now if 84 is picked from here, with assumption that this is for 32, yes. If 84 is picked from this plus displacement, memory plus displacements. If 84 is picked, is my EX included there? Actually, in my code, EX is not, sorry. Actually, okay, let me close this first. EX is not involved at all in my instruction. But then still why it must have taken that. So then 09. If I see 09 in scale index byte, where is 09? I do see that it is ECX and we have taken multiply by 2. So was that 09 here or should have it been supposed to be at 84? Then what must be happening here that it is not giving me actually what I was expecting. So it is ECX multiplied by 2, right? ECX is multiplied by 2. So it is showing me 84 and 09. From where exactly it is coming? If I see 84 here, 84 goes somewhere here. But this is not the case with SIB. Even if I talk about 09, 09 is somewhere here. ECX, ECX. But then scaling factor is not considered here. Now what might have happened here with respect to this instruction that it is picking other details for me. So which is mod and which is scale index byte for me here. If I do the same thing in a reverse manner. In both the cases, it is showing me 8409. Only instruction is changed. So is it because of EAX? OK. Let me take it another instruction too. So it definitely not because of so this definitely is contributing with something is computed. 09 is kept same. But this 84 and 8C is changing. That means it must be because of the register that can be seen as a changed one. seem to be the changed one. But then when I do see this and this, in both the cases, and as well as this 09 was kept same. In both the cases 8409 was kept same, though the format of the instruction got changed. But then how it must be adjusting, how it must be knowing. So this 10 can be seen here, 0A00. This is 10 for you. Okay, not this one. This is address in continuation. So 0A and this whole thing is that 10 represented in a 32-bit manner. But when I do see this, okay, let me try making that change. Let us see what the change is seen there. Now we got 8D, 8D, 8D. Where is 8D? 8D is here. Correct? 8D was here because ECX was multiplied by 4. ECX was multiplied by 4. ECX was multiplied by 4. So that's why this 8D. Now one can see 8D is, but how exactly that 09 is coming over there? So if I use EDX instead here in the instruction, is it going to show me 11, which was shown there? See, here it was showing 9. If I use EDX, then is it showing me 11 or is it going to show me 12? Let us check. So somewhere you have to create a conclusion depending upon what is shown there. So let me check this register, change this register. It is showing now 12. So that's what. So that array is not considered at all. It is assuming that it is EDX only. It is only picking that row and multiplicative factor over there. So 12 was shown here in all the cases for multiplied by 2. But then I am not able to see this particular thing, this 49 wala whatever. I'm not able to get that. So if I multiply it by 4, again let us see what happens. So we will replace this ECX by EDX. See the case. We are interested in this. When we multiplied by 4, it is showing 95 in all cases. Let us see where is 95. EDX multiplied by 4. So earlier it was showing 12, 8D. So 8D was here for multiply by 4 ECX. EX by 4 we haven't tried, but if you try that, you should be able to see that value. So if I see this 95 was shown because EDX was multiplied by 4 and array address was shown added there. Okay, in square bracket, but it is showing me through the star. 95, correct? 8D. 95 8D can be shown because of this multiplication factor by 4. 95 and 8D. But then when I multiplied it by 2, why it is not showing me this 45 and 4D? Though it is showing me something else. What might be the reason? Was it due to probably value for ECX? But it doesn't, it should not matter because ECX, when it is used later, there was no impact of that ECX when it was multiplied by 4, but multiply by 2 when it was done in a multiplicative factor of 2, then it is showing me something which is really I'm not able to digest appropriately properly. I can understand that 0, 0, 0 was meant for this array because it was taken from here. Everywhere, wherever square bracket 0 is added, it was because of that only. And when 10 was added, this 0A was included there in 4 bytes. Correct? In all 3 cases. Okay, so let me try making some small change in the instruction and let us see. Sorry, not here. If I write like this. So it is giving me an error. Impossible segment based multiplier. So if I try to make use of that multiplicative factor, then ultimately it is showing me that part. So what happens here? If I take only this. Zero 9. Okay, in all cases 0, 9 is shown. 0, 9 here is x multiplied by 2. 0, 9, 0, 9. Correct. So whenever I'm trying to take this ECX multiplied by 2, so if I take EDX multiplied by 2, then should it show 11? Let us check. Sorry, 12. 12. Yeah, this one. Not 11, but 12. Same register it is showing, but then it should have multiplied by 2. So it is not taking that multiplicative factor by 2. What must be happening there? So was it not an index treated? So if I add some register here, it is showing 4A 51. So it is definitely from here 4A and 51 because EX was multiplied by 4A. ECX is multiplied by 2. EDX is multiplied by 2. 51. 51 was EDX multiplied by 2. What exactly is happening there? Actually, it is not working with what exactly we had understanding before a while. What is causing issue to generate this problem? something is definitely causing there. Some cause is definitely there hidden behind, which is not giving you the proper realization of what should have happened there. Because see, it is really strange when it shows 4A and 51. So 4A I can see 4A is where 4A was here. It was ECX multiplied by 2. So if I see here, ECX multiplied by 2 was there when it is used with register. But when it is not used with register like this, or if it is used with something array, then it is showing me something which is not digestible at all from the time perspective or from the translation perspective. So task for you, apart from earlier task that I gave, that 0 0 thing shown for EBP, another one task for you, like why it is happening like this. Try to find out the answer. At least try. Let us see like how many of you can understand what is happening exactly there to generate this different value. I can see that when I use with EDX ECX 4A, I definitely see 4A. ECX and EDX, ECX and EDX is used. For 51, ECX and EDX is used by changing their position. But when it talks about only this kind of factor, what happens there? So what if I multiply that ECX by 4, EDX by 4, what might happen? Let me try this and then we'll stop. Now you see very big thing added there now 0 0 0. It is creating a trouble for us. 8D and 95. See here 8D and 95. 8D. This is 8D and 95. ECX multiplied by 4, EDX multiplied by 4. Right in this case. And this 0 0 0 earlier it was adding only 2 zeros, 3 zeros, whatever. Now we are saying 4. Correct? So try to find out what is happening here in all these cases. Okay. Because if you read that manual properly, then you would be able to understand what is happening at that point of time. And it will give you good hold on how the translation process is actually done. Fine. Try this one. So by the way, I'm adding assignment.